Hello, I'm in Honolulu. I'm at the Honolulu Rail, and this is the construction part of the Honolulu Rail, and we're just demystifying some of the structural components of the rail. And I'm looking in the far distance, there's the Honolulu Rail, and it's under construction, and we're going to check it out. It's in the far distance, but that rail line just so happens to pass by OCC over here, Oahu Correctional Facility. I'm in front of OCC, so let's go walk over and take a look at the rail. Okay, the sun is shining bright, and I'm very close to the construction site for the Honolulu Rail, so we're gonna take a closer look. Yes, I'm in front of the, let me see if I can get in the shade a little bit. I'm in front of one of the columns that is supporting the rail. Okay, I'm in the shade. So I'm in front of one of the columns for the rail, and we're going to look at this part right here. We're going to look at that part. And on first glance, I'm going to explain to you what it appears to be. So let's go take a look. So here we are at the construction site at the Honolulu Rail, and we're going to take a look at, so the middle part here, there looks to be a cavity as in another, well, a cavity is like an empty space. Another way you could call it is a plenum, but plenum has a technical definition. Call it, it's definitely empty space. There's space in it. So usually there's only probably three things. Well, there's either materials that go through it, construction materials that go through the cavity, or it's people that access it. And because it's so high up and it's far away, I'm not sure if it's like you hunch in and you go into that space, like you go down. I don't know the height. But I wouldn't be surprised that you were able actually to walk through it standing up. That wouldn't be surprised, because if you've got a large structure and you've got space in the structure, you see that even like access points for buildings. Like sometimes there's mechanical equipment, or in churches, even though people don't see it in the public, they can go up a flight of stairs and they can walk through the behind the scenes. Like even in stages, you go behind the scenes, a stage, so you can access things and walk through it, and this would be no exception. Unless there is just empty space. In that space, there's nothing in there. At least I judge measurements or distances is I look at something that you think is a standard dimension, and then you kind of compare it with something else. So let's just say that here is actually a guardrail and it's 4 feet high. That's presuming it's 4 feet high. So based on that, if this is 4 feet high, then probably the cavity should be 4 feet high. So you probably can't stand up and walk through that cavity. That is, if this is 4 feet high. So that's how you judge distances, judge measurements from a distance. So you need to find some type of reference point. Of course, people are the best reference points. The best reference points, because that if a person walks somewhere and you can see how that person relates to an object, then you know how high something is. Cars are the same way. Cars, like a parking space could be 10 feet wide by 20 feet long. So if a car can pass through something, you know that the width of wherever they're passing through is a certain dimension, that it's at least 10 feet wide. And there's close calls. That's why you see signs on bridges that says the clearances. Sometimes the trucks don't make it through, or they end up shearing off the top of the truck. Now we're gonna look at these. They're there's wires coming out of it, and there's 8 of them. 1, 2, 3, 4, 1, 2, 3, 4. They're conduits, meaning they're spaces for something to pass through. So either it's some type of space for pipes to go through, or some type of space for perhaps steel post-tension cables to go through. And post-tensioning it's a form of creating a stronger structure. So here we see one piece of concrete piece, one concrete to the right, and one large piece of concrete on the left, and there's a gap in between them. And then you've got these, I'm going to call them pads. And they're not, if you look at it, one pad is shorter than the other. They're not exactly the same width. What I just told you, so what does that mean, right? That there's a gap between the two concrete structures. Let's talk about that. It means that there's movement. It is accommodating for the movement. You could think that structures don't move, but they do. They move, they settle, and they need to be able, segments of it need to be able to move independently of each other to accommodate for movement. That's why we have, for example, roof shingles. Roof shingles are able, so you're able to, well, it's also installation too, but there's a reason why that there's certain sizes for things, and that there's gaps. And the gaps, in this case, it's just as or more important than the object itself, because you need to be able to account for movement. What I was saying about these pads, there's other ways to, there's other terminology for the pads. It could be called bearing pads. Bearing pads is a good structural term because they're pads in order for something else to bear on the column. So bearing means that there's something directly resting, there's some load coming from, they're coming from here, the top, and it's bearing directly on the column. So that's, the correct term would be called a bearing pad. When you design something, there has to be a point. Well, a lot of times when you design something, you have to control where it's going to separate. And that's probably one of the most important things about design, is knowing where it's going to separate from another object in the design. This column here that doesn't have the decorative piece on the bottom, and this pad is a little less wide than this pad. And then I'm moving over here to this column, which has the decorative, it looks like the decorative sun. Again, this pad over here to the right is a little bit smaller, so obviously there's a reason for that. Here's the close-up. So here's one of the pads. It's not as wide as the other one, and this is for. So we were talking about the concrete, this concrete piece directly laying on top of the, bearing on top of the column, and this one is not. It's on a beam, so structurally, that's called a moment connection. This is a moment connection. So here you can see the reinforcement bar coming out of the beam. And then you've got there are 16 of these round tubular things that they look like they're capped, meaning that, well, because the rebar's coming out, that's obviously not the finished product. Rebar is a short term for reinforcement bar, and by definition you're not supposed to see, in the final product, you're not supposed to see reinforcement bars in a structural situation unless it's used for something else. But in a structural situation where you've got concrete and reinforcement bar, you're not supposed to see the reinforcement bar. If you do, you've got a problem. That means that the structure is compromised, and well, I wouldn't say that means if you keep on leaving it alone and the reinforcement bar is exposed, the structure could eventually be compromised, or it's on its way to be compromised. But that could take a long time. I've seen it in other countries where it could take decades for the structure to be compromised. It depends on the weather and all other factors that wear down the building.